Good evening to all.
Good evening, sir.
In this video, we are going to discuss about the case study on the anti-lock braking system in control systems. Generally, the anti-lock braking systems plays a major role in every vehicles, especially for cars and bikes. It will be a crucial role for making more effective performance. And moreover, the government of India announced that after 125cc, all must put anti-lock braking system in their own vehicles, especially for 125cc, because it is having a high pulley power, so that it may not be controlled by the human. So that the government of India planned that the ABS is mandatory for all the vehicles, so that to avoid the unnecessary skidding of the humans. So in this video, we are going to share about our ideas regarding the anti-lock braking systems, and most probably the thing which is performed based on steady state error analysis, because the steady state responses is the one. It is only providing the anti-lock braking system to be a more efficient and more controllable manner. So let me see how these performance will be enabled based on the steady state error and performance.
So next is the objective of steady state operation in auto braking system. So the main objective of steady state operation in auto braking system is to keep the vehicle slip, the wheel slip at an optimal level, so that the maximum friction is obtained between the road and the tire.
So, most probably they are using position, velocity and acceleration. Based on this, we need to control the stability of the system.
So this helps in preventing wheel locking while braking, and also by maintaining the steady wheel speed and control brake pressure. ABS ensures better vehicle safety and also steering control, and also helps in reducing skidding. So overall it is safe and also provides effective braking performance.
So I'm going to say the steady state condition, how it is used in ABS, which is known as anti-braking system. In which is how it is used means when we give a brake in normal thing, it stops the vehicle. When we give
Anti-lock braking
system, it automatically see the wheels rotation. If it is 50 to 20% means it goes maximum.
Automatically lock the performance,
Yes.
and it may be provided the users.
Yes, sir. So it does not increase or decrease rapidly. So in this I convey that it is, so we can say that it is a steady constant level.
So that it may not provide any skidding access
Yes.
to the users.
So it one of the steady state things.
Okay, let me see about the steady state error in auto braking systems, which is mainly difference between the desired wheel grip levels and
So
the
the main
actual.
purpose of this ABS is to avoid the errors based on the generation of the vehicles.
Yes.
Yes.
And the desired wheel slips and the actual wheel slips when the brake is settled. And in the anti-flip-flop levels, it is try to maintain the particular flip-flop levels, or overall 22%.
Flip-flop is zeros and ones, the checking
Yes.
conditions.
At the 20% to maintain the wheel breakage properly, but it cannot track the desired wheel slips. So it reminds some errors in the circuits. That is called steady state error. If it has a low state, the performance to be better. But if it is have a high steady state, the control accuracy or the performance to be reduced. To overcome these issues, we can use the integrated controllers in the auto braking system.
Integrated controller, program controller, derivative controllers we are using to minimize the errors and make it as a more performance.
Okay, let us see about the effect of the controller using steady state performance. In steady state condition, the P controller is used to reduce the error, but it cannot be controlled completely, because in PA and PID controllers is used to adjust the integral action and which helps to reduce the steady state error to 0 or almost 0. In modern ABS system, It is used to control the error, and it is used in the adaptive controllers which adjust the control actions.
While applying the brake, it may be happen at the sudden brake. We notice that while applying the brake.
Which adaptive controller is used to adjust the control action based on the road condition between the stable braking system and better performance.
Yes,
Okay, now I'm going to explain about the example of the steady state ABS performance. So in this topic, we are basically talking about how the ABS performs after the braking slip stops and the systems became stable. So instead of locking and slipping too much, this ABS constants an optimal slip, so for the maximum gravity and the control of the vehicle. For example, in a dry road, the friction is very higher. So the ABS quickly adjusts the brake pressures and holds a constant slip. So the vehicle stops smoothly and safely. That reduces the skidding. So in the wet road, the friction is very lower. So the ABS reduces the brake pressure and holds a balanceful slip. In this condition also, the vehicle stops safely and safer. But the distance is slightly longer than of the
So
dry
it is
road.
also based on acceleration, position, velocity. Yes.
And in an icy road, the friction is very lower and unstable. So the ABS keeps continuously changing the brake pressure frequently. But in that condition also, the vehicle stops safely. Loss of steering. So on comparing these road conditions, the ABS holds an optimal value for a slip for the maximum safety of the passengers.
Okay. From this, we have concluded that all those steady-state error analysis and performance we have discussed in this video. And moreover, if we are reducing the steady-state error, then it will be very efficient for users to become a more efficient manner. So, in Government of India, they announced that above 125 only they have to be ABS in their own vehicles. But in future, it may be reduced below 125 cc or so. They are planning. If it is planning means, then all the vehicles has to be uploaded as ABS vehicles, so that the accidents will be minimized, and in future it may not be appear as a more number of accidents in future, so that the ABS plays a major role for their own vehicles. Thank you.
Thank you, sir.